Okay, so welcome to part 10 of Negative Sequence Made Easier. And in this one, we're going to go over the SEL 710 relay. And we're going to be above FLA as an average. Okay, so we're going to start at FLA with all three, and one of them is going to go up. So that means that whenever the average is above FLA, we're going to use this equation right here, not this equation. So make sure that you read the little fine print, and we're going to go over this stuff also. Okay. And then this average right here, they've given us all of it. And as I said before, this is the absolute value. In the last videos, we had to deal with this as well. This absolute value means magnitudes only. That's all. We do not care about direction, okay? We want the positive magnitude only, all right? So we're going to start with all three phasors. They're going to be balanced at FLA, okay? And then we're going to leave two of them alone. We're not going to change them. We're only going to ramp one of them, ideally A phase, up until you get a unbalanced pickup. So this is our testing procedure. What do we have? Well, we have several things here. This is a setting out of the relay, but let's go ahead and define like IAV, okay? IAverage is going to be the absolute magnitudes of these. And we know what these magnitudes are going to be, except for IA. That's the one we have to find out. The other ones are going to be FLA. So we just went ahead and substitute that in here. And so we've got IA plus FLA plus FLA. We know what FLA is going to be. It's going to be some kind of setting that we pull out of the relay. And then when you get this, I just divided both of these by 3 to break it out. And so that's what we get right here. And then I just took all of this and I put it up here. So that way we have it for later, because I am going to erase some of this stuff. And then that's this right here. So now we just need to talk about this IM, and then we can get into the real calculation. So what is IM? IM is the max of whichever of these two values, okay? So you have to calculate both, and whichever one is higher, that's the one you're going to use. And again, we're going to use absolute values here, okay? So that means that we care about magnitudes only, and only the positive value. Okay, so if it was negative, it's going to become positive. So this I max right here, what is this? Well, this is the absolute values of each of these, right? The I have, this is the absolute values of each of these. So really, the only thing that we care about is magnitude. And if you subtract it, it becomes negative. Throw the negative away. All we care about is the positive of everything in the magnitude. Okay, so that's what this is. And so our situation, because of how we're testing, only one of these is going to be used. And the way that I like to think of it was, our average is going to stay closer to FLA, okay, than it is the maximum, okay. It's going to stay closer to FLA than it is the max. Because the average is going to be weighted by 2 FLAs and only 1 max, okay, and therefore also one of the minimums is going to be FLA, right? And the average is going to be weighted closer to the minimum. So that's the way I like to think of it. I feel like that helps. But if that didn't really get it through, then let's draw a little graph and we'll figure it out, okay? So imagine that we are testing with all of these values right here. This is shot 1, shot 2, shot 3, and shot 4. And we're going to test with each of these. So if A phase was 1, B phase is 1, and C phase is 3. We're only raising one of these. The average goes up here. Okay, that's what I'm doing. So when we do that, you see this, and this is the same kind of test we're doing. We're leaving 2 low at FLA, and 1 is going up. And so when you do that, what happens? Well, you have this, and this becomes, when you subtract it out, it'll be up 1.33. That's what this will become, right? That 1.33, well, if you do it the other way for the I min, over here, you're going to get 0.66 negative, right? Throw the negative away. Still, this value on the right is less than this value on the left, okay? So that means that, again, just like I said, we're going to be sticking with this one right here, okay? The next one that we're going to talk about, 3 amps on A and B and 5 amps on C. And with that one right there, which is this right here, the average is 3.66, okay? Plug all this into here and we get 5, and then you subtract this out, the max minus the average, and you get 1.33. You do the same over here, the minimum minus the average, and you get negative 0.66. So again, on this one over here, the I max minus the average is always greater than the other way around, okay? So hopefully that one helps you to see it. So, and this was the same kind of test that we just did on the one before it also, okay? These are all, we're only raising 1 magnitude, all right? So the next one is going to be 4, 4, and 1. Now we're going to have 2 values that are going up and only 1, or maybe 1 value going down. Doesn't really matter. now that 1 is a minimum, and the average is 3, by the way, okay? The I min minus I average is now -2, and then 4 minus 3 is, 1. Oh, now the -2 is greater, okay? And it's because of how it's been weighted closer to the average, okay? And then if you look at this last one right here, 2, 2, and 1, well, I mean, 2 of them are the same, and 1 of them is different, and that's the 2 that are the same are higher than the other one, and so when you look at the absolute value again and subtract it out again, this one wins. So we are not testing in this method. We are testing in using a method like this over here. Okay. So this is the equation that's going to apply for the test method that we are using. So I'm going to erase a lot of this stuff here and get ready for the actual calculation that we need using the Imax minus Iav for our Im. So this is our default equation, and let's go ahead and break this out a little bit further. Actually, let's just go ahead and simplify this equation just a little bit. Let's take this and just multiply both sides by Iav, and that way when we get ready to substitute it in, it's not as much to write. So this would be UB times Iav equals Imax minus Iav, okay? And now let's go ahead and substitute in for what Imax and Iav are. So UB times Iav is going to be 1/3 Ia plus 2/3 FLA, that's in parentheses, equals Imax. Imax is Ia minus Iav again, which is in parentheses 1/3 Ia plus 2/3 FLA. So let's go ahead and distribute. We're going to multiply this out to both terms, and then we're going to take this negative and distribute it to both of these. So then what do we get left after this? We're going to have 1/3 UB Ia plus 2/3 UB FLA equals Ia minus 1/3 Ia minus 2/3 FLA. And me personally, I'm just tired of all these threes, so I'm going to multiply everything by 3. So let's go ahead and just do that real quick. This will be UB Ia plus 2 UB FLA equals 3 Ia minus 2 FLA. And let's simplify this term, and then we'll move this to the other side, and then we'll move this to the other side. So that way we're trying to get all of our IAs together, okay? 2 UB FLA, that's this term. Then we'll move this one over, plus 2 FLA equals 3 Ia minus Ia. This is just going to be 2 Ia, so I'll just write that right now. 2 Ia, that's this. And then the last one is this, which is going to be now minus UB Ia. So now let's simplify this a little bit more. We can take this 2 FLA out of the left. So 2 FLA times UB plus 1 equals, and we can take Ia out of the right. So this is just going to be Ia, and this is going to be 2 minus UB. Divide both sides by 2 minus UB, and you'll have Ia by itself right here. Just divide both sides by that. That'll get rid of it on the right. And then we'll just start with Ia equals, and it's going to be all of this right here divided by all of that, which is 2 FLA in parentheses UB plus 1 divided by 2 minus UB. There you have it. So following this formula that we're doing, this is the way that you would do it. This looks a little bit like a D, so I don't want to be confusing. There you go. So that's how you would do this, and hopefully that's not too muddy. So as a quick example, a lot of these relays, you might see a UB, under balance is set UB equals 20% or 20, which is, in this, that's why we had the 100 up here. So this is going to become a 0.2, okay? So that's what you would put as a setting in there. And so if you were to do that, this would be 2 FLA. And actually what I'll do is I'll just distribute that to everything inside of here. So that way all you have left is just an FLA, okay? So FLA, and this will be distributed inside. So let's do 2 times UB, which is 0.2, plus 2, all divided by 2 minus 0.2, which equals, well, this is going to be 0.4 plus 2, which is 2.4. Oop, this is going to be FLA times everything. FLA times 2.4 divided by, and on the bottom, it's going to be 1.8. And this is essentially right here, FLA times 4/3, okay? Or 1.33 FLA. So this is the SEL 710, and like I said, this equation right here, as long as you follow the setup that we are doing over here, then you should be just fine, okay? So hopefully this helps, and thank you.